Assalamualaikum and a very good day to all of you. So now we are going for the next chapter, which is the second last chapter, electrical science theory. Okay, so we are going to discuss today, which is the first part, which is resistor series and parallel, how to apply Ohm's law to find the current and potential difference, and how to use a power formula. For the Kirchhoff law, or we can also call it Kirchhoff law. Kirchhoff law is, we are going to put it in the second video. Okay, let's proceed to the next one. Okay, so basically, as you can see that electricity, okay, so electric, based on the name itself, electric always be related with the flow of electron. Okay, so when there's a movement of electron, definitely you are going to have a electric. Okay, so the directions of electric follow the directions of positive charge. However, as you can see that positive charge doesn't move, but the only charge that move is electron, especially in what? In conductor material. Okay, so we have three types of material. We have conductor, we have insulator, and then we have semiconductor. Okay, we have semiconductor. Okay, the difference between this material is conductors. You can see that the electron freely to move, okay, and didn't actually bond and didn't tightly bond to the nucleus. For the insulator, electron hardly, or we can actually say that there's no electron move, there's no free electron to move. That's the reason why insulator is not a good electric material. Okay, and we have semiconductor, and semiconductor is basically it can be conductor, it can be insulator, it can be conductor, it can be insulator. Okay, so there's only two material that represent semiconductor, which is germanium, and another one is silicon. Okay, yeah. Okay, so I already explained here what does it mean by conductor. Okay, so metal is a very good conductor, which definitely they are going to have a free electron. So when they have a free electron, it means that electron can actually move, so therefore is a good electricity material. Okay, this one I already explained. Okay, so as you can see that electric battery, or we can actually say that is a power supply, is one of the source of potential difference. Okay, so when you have a potential difference, definitely you are going to have a flow of electron, or we can actually say flow of current. Okay, so I'm going to give it to you the simplest example to represent what is the effect of potential difference to the current. Okay, so as you can see that battery is consists of two terminal, which is positive and negative. Okay, positive and negative. Okay, so you imagine that the battery has a two level, which is this one is positive, higher than the negative one. Okay, and the difference between these two we put as a potential difference. Okay, so what happened is when you have a difference in terms of level, the flow of electron, or you can imagine as a flow of water, going to be higher. What if I increase the V? What if I increase potential difference? What happened? Okay, I increase V, and what happened to the flow of electron? What happened to the flow of water? Definitely is going to be more higher. Okay, so what if you have two same level? Is there any flow of water? Yes, the flow of water going to be static, and that's the reason why we need to have two potential difference, which is positive and negative, to provide an energy, because basically the potential difference going to provide a potential energy for the current to flow. That's the reason why we need to have two different levels. And if we didn't have any difference in level, it means that there will be no flow of current or no flow of electron. Okay, so do you understand about the potential difference and the relationship with the current? Okay, so the potential difference also we call as a voltage. Okay. Okay, so here I already mentioned that we have two terminal, a positive terminal and negative terminal. Okay, so what is the directions of the conventional current? Conventional current. Yes, okay. Okay, so example, if you have an electric circuit with a battery over there, okay. Okay, so the current flow going to be from positive to negative or the other way around? Yes, the conventional current going to move from positive terminal to negative terminal. Conventional current flow, that's what we call as a conventional current flow. If we have electron flow, is going to be opposite direction with the conventional current flow, which means that the electron going to move from negative and then towards the positive. Why? Because electron is negative charge, is going to be attracted to the positive terminal, okay, and then it's going to be repelled by the negative terminal. Okay. Okay, so here I already show you a proper way, a proper diagram of the conventional current flow and also electron flow. Okay, so basically the wire going to be consist of conductor. The reason is because only conductor have a free electron, therefore electron can actually move in compare with the insulator and semiconductor. Okay, so current here we represent by I equals to number of what we call as a charge divided by time. Okay, so it means that here charge per unit time. So as you can see that the current flow always be constant whether there's a resistance or not. Okay, because the current flow is basically the charge flow, and what type of charge is going to be the electron. Electron cannot be destroyed, cannot be destroyed and cannot be created. Okay, so if example you have 5 ampere and then there's a wire over there, definitely you are going to produce 5 ampere. But why when you have a resistor, okay, and what is the function of resistor? To resist the current flow, or we can actually say that to limit the current flow. Okay, so example from point A and then you have resistor here to the point B. Why you feel why when it comes to the calculations you put 5 ampere here, but at the end is only happen to have 2 ampere. Okay, there's a misconceptions over this theory. Okay, currents always be constant. Supposedly is going to be 5 ampere, but why is become 2 ampere? Because based on the formula, current equals to charge per unit time. So 2 ampere here, it means that you measure in a certain of time. Okay, so example, if you measure 2 seconds, so in 2 seconds the only charge can actually flow because of this resistance is 2 ampere. But what if you put it longer? Yes, what happening is going to be 5 ampere also. Okay, because you measure in a certain amount of time. That's the reason why you get 2 ampere but you didn't get 5 ampere. Okay, that's okay, got it. Okay, let's proceed. Okay, so here okay, what happened is the difference between battery and resistor. Battery basically provide energy. Okay, like I mentioned before, battery provide potential difference. That potential difference basically give the energy, which is what type of energy? Potential energy to the charge, which is electron to flow. But resistor here, the function is to limit the current flow. That's the reason why you can actually feel that sometimes there are certain like wires, your handphone feel some thermal energy over there is because of resistor convert electrical energy into what? Thermal, or we can call as a heat energy. Yes. Okay. Because it's going to limit the current flow, it's going to give a resistance to the electron flow. That's the reason why, because of electron collide with all the resistance come from resistor, and that's the reason why it's going to convert to thermal or heat energy. Okay. So based on the I already mentioned resistance is how difficult for the electric current to pass through. So increase of resistance, definitely you are going to decrease the current flow because there's a lot of resistance over there. Okay. Here we are going to connect the relationship. We are going to find the relationship between resistor, current, and potential difference. Okay, here I'm not going to use E here. Mostly we are going to use V, or another symbol going to be EMF. Okay, E over here mostly used for energy, but to be official, it's better for you to use V or EMF. Okay, so what happened here is, based on the Ohm's law, Ohm's law state that current is directly proportional to the potential difference, inversely proportional to the resistance. Okay, so please make sure that you put it in the correct arrangement. Okay, you cannot put R equals to V over I. This is totally wrong because resistor doesn't depends on current, not depends on voltage. Resistor is basically depends on the material that build this resistor. Okay, yes, resistor have their own material. That certain material going to provide higher resistance, certain material going to provide lower resistance, and also they depends on length and area. That's the reason why for the resistance, basically the formula going to be resistivity L over A. But this one you don't have to. I'm not going to explain deeper for this one because this is quite high level. Plus, I think you already learned this in SPM. Okay, but the things here I want to show to you is the relationship of the Ohm's law. When you have higher potential difference, like I mentioned before, if you have higher level, your current flow going to be higher. So what happens is current flow is your current. Higher level is your potential difference, and when you have higher resistance, your current flow going to be decrease. Okay, if I ask you to state Ohm's law, please do not give the formula. Please explain like current directly proportional to the potential difference, inversely proportional to the resistance. Okay, now I'm going to explain to you about resistor, which is we have two arrangement of resistor, which is series and parallel. Okay, so I know that most of you just memorize the formula. Okay, it's going to be a bit trouble for you to solve the question, for you to find the current and potential difference for each resistor when it's actually combined in series and parallel. Okay, so first thing first, I'm going to explain about resistor in series. Okay, so resistor in series, example, if I have R1, R2, and then R3, and this resistor is basically connected to the power supply. Then we have a positive and negative. Okay, so what happened is when you have a car, so basically what happened is when you connect to potential difference, then definitely there will be a current flow. Okay, so the current flow doesn't have any different path for them to flow. Okay, so the only path they can actually flow is this one, and that's the reason why you can actually see that the current for R1, R2, R3 going to be the same thing, because that's the only path they can actually taken. If you actually put electron as the movement to represent the movement of current flow, it means that there's only one path for the electron to flow. Because why? Electron basically attracted to the positive terminal. So for electron to move to the positive terminal it needs to flow in only this one path. And that's the reason R1, R2, R3, you are going to have the same current flow. Okay, I1 equals to I2 equals to I3. And how about potential difference? Okay, when it comes to the potential difference, okay, like this. Okay, R1, R2, and R3. Okay, when it comes to the potential difference, you imagine that positive here are going to be this one, and this negative connected to here, basically this one going to be negative, as if that this thing, the combination of R1, R2, R3, the combination of potential difference from R1, R2, R3 is basically the same thing as power supply, because it's like one potential difference here, positive and negative. And that's the reason why potential difference at V1 should be plus with the V2, should be plus with the V3, for you to get the total potential difference same as the power supply. Okay, it's like one big battery over there. Okay, that's why when it comes to the formula, we have V equivalent. Okay, V equivalent is basically a V total. Okay, the V total here is going to be your potential difference. You're going to be your power supply. So V equivalent will be equal to what? V1 plus V2 plus V3. Why it become plus is because, like I mentioned before, you imagine this is like one big battery, positive here and then negative here. Okay, so what happened is the combination of all potential difference from R1, R2, R3 are going to be equal to the V equivalent or V total. Okay, so based on the Ohm's law, V equals to IR. Okay, you put this into these equations, then you are going to get I equivalent R equivalent equals to I1 R1 plus I2 R2 plus I3 R3. But I mentioned before, the current flow here going to be the same, because there's only one path for the electron or current flow to move. And that's the reason R1, R2, R3, and for the battery in series going to have the same value. Okay, so if I put it here, I equivalent will be equals to I1 equals to I2 equals to I3. So what happened here, that's the reason why you are going to get the formula for the R is going to be R equivalent for the series is R1 plus R2 plus R3. Yes, it means that you just add up everything for you to get the resistance equivalent, or we can actually say resistor total resistance. Okay, and how about parallel arrangement? Okay, so for a parallel arrangement, okay, I'm going to show it to at the next slide. Okay, for the parallel arrangement, okay, example, if you have three resistors, R1, R2, and R3, basically connected to the potential difference. So this is R1, R2, R3, and this is going to be potential difference, or you can actually say that it's basically a power supply. When you connect it to the power supply, what happened is, the first thing first that comes in mind, why in parallel the V going to be the same value. Okay, you imagine that when this line connected to the positive, everything going to be positive at this side. Okay, and this line connected to the negative, and that's the reason why this one going to be negative side. As you can see that this one equals to V, R2 V2 going equals to V, and R3 V3 equals to V, because you can actually say that as if this is a battery, and that's the reason why you get V same for all R1, R2, R3, which is going to be the same with the V for the power supply. Okay, so V equivalent, or we can actually see V from what? V from power supply. Okay, V from power supply going to be V1 equals to V2 equals to V3. But what about current? Okay, for the current flow, as you can see that you imagine that there's a resistor here and here. Okay, so this is R1, R2 and R3 connected to potential difference. Okay, so current flow is basically electron flow. Imagine electron flow is like one of the big fan of the artist. Okay, imagine R1 you have here cow. Okay, and then R2 we can actually put an artist such as maybe BTS. Okay, here R3 maybe you can put like The Rock. Okay, so example, The Rock is the most popular artist from compared with cow and BTS. So electron you imagine as a fan. Okay, so this big fan example, if this fan actually fall in love with The Rock, so it's going to be attached here. Okay, second electron, another fan. Okay, maybe this second fan attract to who? Cow, and it's going to attach to cow. Okay, what about third fan? Maybe the third fan or electron going to attach to The Rock. So as you can see that the different amount of charges flow to the resistor, and that's the reason why there will be a different the different value of current flow for each resistor in parallel arrangement. Okay, because of why? Because electron have can choose between three paths, whether to go to the Rock path or BTS path or cow path. And that's the reason why you get current for each resistor going to be different. Okay, another things that going to affect the value of current is going to be the value of resistance. So higher resistance, example BTS doesn't have any fan, so means that maybe like BTS have one fan, so the current flow here going to be less because BTS give you higher resistance. It's going to reject the fan. Okay, and that's the reason why there's no fan going to attach to BTS, but there's going to be a lot of fan attached to The Rock and cow. Depends on their popularity, which is popularity I assume is depends on the value of resistor. Okay, got it? Okay. Okay, so here, you get your voltage for each one going to have the same value. However, for the current going to be different. Okay, for the I equivalent, how you get the I equivalent? From the power supply. Okay, I'm going to show to you how to get the value for the I equivalent after this. Okay, so I equivalent going to be I1 plus I2 plus I3. The combination of these three going to give you the total current, or we can call equivalent current. Okay, so based on the formula of Ohm's law, which is V equals to IR, which is I equals to V over R, you insert this value, so you are going to get V equivalent R equivalent equals to V1 R1 plus V2 R2 plus V3 R3. Okay, like I mentioned before, okay, your voltage is basically the same, so V equivalent will be equals to V1, V2 and V3, and that's the reason why you are going to get your resistor equivalence will be 1 over R1, 1 over R2 plus 1 over R3. Yes, okay, but please make sure that you didn't memorize. Okay, make sure that you understand based on the concept how the current going to be the same for series but different for parallel, and how about potential difference going to be the same for parallel but difference in series. Okay, so the things that I need to mention here, I need to emphasize here, double extra careful with the 1 over R equivalent. Mostly students forget to put 1 over. Okay, so please do not do please avoid this kind of careless mistake. Okay, Okay. Okay, so as you can see that I'm not using E here. It's better for you to V or EMF, which is the official symbol. Okay, so this is basically for series and the series, and this is basically for parallel. Okay, so please do not memorize, please make sure that you understand how to get that value. Okay. Okay, let's move to the next one. Okay, before we proceed with the calculations for resistor series and parallel, okay, now we need to compare between parallel and series for certain situations. Okay, here, okay, I already mentioned that current has only one path to flow for series. However, current going to split into different path for parallel. Okay, that's the reason why you are going to get same current for series but different current for parallel. Okay. Okay, but potential difference is basically vice versa. For the series, the potential difference is going to be difference, but for the parallel, potential difference for each resistor connected in parallel going to be the same. Okay, so for the series, and that's the reason why you can see that for arrangement of resistor, okay, we can actually say resistor is like a bulb. Okay, a bulb that connected in parallel are mostly used in a building. The reason why is because of, as you can see that for the current flow, for the bulb is going to have a different path. So it means that even there's one of the bulb have a problems, there's still a current flow in compare with the series. Example, we have this kind of problem, then the second bulb not going to be turned on. Okay. Okay, so and then another reason why the resistance is basically connected in parallel is because you can see that when it comes to the parallel circuit, the value of resistance is 1 over R, which is basically very, very small. So what happens is the current flow going to be higher. Okay, in compare with the series, okay, the resistance, total resistance is quite large. Therefore, the current flow here over here going to be quite small. Okay. Okay, so let's start with the calculations of this question. So right now, the question asks you to find the equivalent resistance, which means that you need to find the equivalent resistance, and then the question asks you to find the current and the voltage for the resistor 1 ohm, 4 ohm, 2 ohms, and 3 ohms. Okay, so I'm going to show you how to get the answer for this one step by step. Okay, so first thing first, when you get this kind of questions, you need to find a resistance equivalent. The reason why you need to find the resistor equivalent, because you need to find the total first, and after that you are going to use the Ohm's law for you to find the current. Okay, so the resistance equivalent, mostly we are going to start with something that parallel like this, and then we make it simplified, then we are going to find a total resistance. So now we have 6 plus 2. 6 plus 2 is basically in series. 6 plus 2 is series, so it's going to be 8 ohm. Okay, so okay, so it's going to be 1 over 6 plus 2 plus 1 over 4. So you are going to get 1 over RA. So I assume that this area is going to be RA. Okay, so what is the value for RA? Okay, please make sure you don't forget to put 1 over RA. So 1 over 4 plus 1 over 8 divided by answer. So you are going to get 2.67 ohm. Make sure that you put the units over there. Okay, next is, okay, once this thing already done, what happen is your resistance going to be only one resistor. Okay, so means that this one is RA, the combination of series and parallel over there. So this is going to be 1 ohm, this is going to be 9 volt, this is going to be 3 ohm, and this is going to be 6 ohm. And as you can see that this is Connected in what? Series or parallel? Yes, it's connected in series. So when it comes to the series, means that you just add up everything. So supposedly for the resistor equivalent, you are going to get plus 6 plus 3 plus 1. So you are going to get 12.67 ohm. Make sure that you show the working steps. Make sure that you look at the marks. How many marks? And then make sure that your working step enough for you to get the full mark. Okay? Okay, once you find the resistance equivalent, then you know what is the value of current that provided by this potential difference, okay, provided by this power supply. Okay, so because of this kind of resistance and with this kind of potential difference, so what is the value of current that affected by this potential difference and this resistance? That's why we are going to use V equals to IR. Okay, so the current equivalent, which is the total current flow because of all this resistance, going to be V is 9 divided by 12.67. So it means that you are going to get 9 divided by 12.67. You are going to get 0.710 ampere. Okay, so based on these diagrams, the current flow going to be 0.710 ampere. So what is the value of the current for 3 ohm, 6 ohm, RA and 1 ohm? Yes, because it's in series, current will be the same. So current for I3 going to be 0.710 ampere. Current for I1 is going to be 0.10 ampere. Current for 6 ohm here, okay, is going to be 0.170 ampere, and current for RA, the combination of all these things, going to be 0.170 ampere. Okay, because it's in series. Therefore, from this equation for the I3, you can actually find the voltage. Okay, so V equals to IR. So I going to be 0.710 times with the 3. Then you are going to get the value of potential difference apply at the resistance 3 ohm times 3. So you are going to get 2.13 volt. Okay, so now you please also find the value of potential difference for this one, 6 ohm, okay, sorry, 1 ohm and RA. Okay, so for 6 ohm, the same thing, V equals to IR also. So 0.710 times 6, so you are going to get 4.26 volt. Okay, what about 1 ohm? V for this is 6, this is 3, V for 1 ohm going to be 0.710 times 1. Then you are going to get the voltage going to be 710 voltage. Okay, so what is the value for the RA? You can actually use the V equals to IR, or the easiest thing is the total voltage is 9 volt. Okay, for the series combination, the total voltage going to be the sum of all the resistance in series. It's the sum of voltage for the resistor arranged in series. So 9 volt over there, you minus with the 2.13 here, you minus with the 4.26 here, and then you minus with 0.70. So what is the remaining potential difference that going to apply in a resistance A? So 9 minus 2.13 minus 4.26 minus 0.71, then you are going to get 1.90 volt. Sorry, this is not resistance, this is going to be VA. Okay, so if you want to solve this kind of questions, you need to make sure that you open back all the resistor that you calculate before. So right now for this question, for this part, I calculate series for 6 plus 2, and then I parallel with the 4 ohm, then I get 2.67 ohm for this combination. So I'm going to open it one by one for me to find the current and the voltage for each one. Okay, you need to open back. Okay, before this you just folded everything, Okay, you combine everything. Right now you open it one by one. That's how you solve this kind of question. So means that for 2.67 is the combination for the resistors 6, 2 and 4. So you find first the current over there. Okay, so if I focus only on this part, so I'm going to get 6 plus 2 is 8. Okay, like I mentioned before, you open it one by one. So I open it like this first. So this is 40. Okay, so the current flow, so the voltage apply for this, okay, before, okay, this one when you combine is going to be 2.67 ohm. Okay, so the voltage that apply at 2.67 is what? Is going to be 1.90 volt. And how about the current applied at the resistor A? Okay, so you can see that like the one I draw before, as you can see that for this one you have 3 ohm here, you have 6 ohm, you have 1 ohm and RA. So because it's actually connected in series, so the current pass through the RA going to be, yes, very good, is going to be 0.710 because it's connected in series. Okay, so you don't have to find using the formula, you can actually just use based on the concept itself. So here for the current A is going to be 0.710 ampere. And how about voltage for the 8 ohm and the 4 ohm? 8 basically the combination of 6 and 2. That's the reason why you get this kind of value. Okay, for the voltage applied at 2.67 is going to be 1.90. Okay, because 8 ohm and 4 ohm connected in parallel. So what is the value of the voltage applied at the 8 ohm and the 4 ohm? Yes, when it comes to parallel, the voltage going to be same. So parallel at 8 and 4, so means that your voltage for each one going to get 1.90 volt. Okay, so from 1.90 volt, so you are going to get the current for 4 ampere. V equals to IR, so I equals to V over R, so you are going to get 1.90 divided by 4. So supposedly you are going to get 0.475 ampere. And how about 8 ohm? 8 ohm, the same thing here. Okay, V equals to IR also. Find the currents over there. So 0.47 current V is 1.90, R is 8. So 1.90 divided by 8, so you are going to get 0.238 ampere. You can actually find using here, okay, but you can actually use that. What is the current flow into the 8 ohm and 4 ohm? Yes, it's going to be 0.710. So if you use 0.710, you minus with the current flow for the 4 ohms is going to be, you're going to get the same thing as this one. 710 you are going to get 0.710 minus 475, you are going to get 0.235 ampere. Okay, so you can actually see that there's a lot of method. You can use V equals to IR, or you can actually just use minus because of why? Like I mentioned before, current going into equals to currents going out. If you have 5 ampere into, definitely you are going to have 5 ampere out. So now the current flows into 2.67 is 0.710, which is same as current flow into combination of 8 and 4, because this one you are going to get 2.67. So current flow is 0.710. So 7.10 are going to divided based on the value of resistance to 8 ohm and 4 ohm. That's why you can actually use this kind of method. Okay, and then okay, so now for the 8 ampere here, you are going to break it into 6 ohm and 2 ohms. That's the reason why I said you open it one by one. Okay, you reverse back. Okay, so it's going to be, here is 6 ohm and here going to be 2 ohm. So you are going to get for the current flow here, what is the value? because it's connected in series. So the current flow for 6 ohm and 2 ohm going to be, yes, 0.235 ampere flow at 6 ohm and flow for 2 ohm because of why? Series arrangement. Okay, so what is the voltage for 6 ohm and 2 ohm? It's not going to be the same because series for the voltage going to be different. So you use V equals to IR for 6 ohm here. IR, so you are going to get I is 0.235 multiplied by 6. So supposedly you're going to get 0.235 times 6, 1.41 volt. And voltage for 2 ohm, the same thing, 0.235, current going to be the same, but the potential difference is going to be different. 5 times 2, so you are going to get 0.47 volt. Yes. Okay. Okay. So if you actually combine this 0.47 with the 4.41, you're actually going to get 1.90. Okay. So basically, it's pretty easy, but you need to know the flow of the current and the flow of the voltage for you to get the value. Okay. So you need to open it one by one. That's the reason why you need to start first with the resistance equivalent. Find the current equivalent. Find the current that going to comes out from the power supply because of this total resistance. And from there, you are going to use the concept of series and parallel current and voltage for you to find the answer. Okay. There's going to be a lot of method, but this is one of the method that you can actually use. Okay. Okay, let's proceed to the next one. Okay, so basically, this is the step-by-step for you to solve the questions. The first thing, definitely, please find the R equivalent. Okay, find the total R equivalent. Make sure that you use the correct formula, which is for the series is you total everything up, but for the parallel you need to 1 over R. Once you find the R equivalent, the next thing is you need to find the I equivalent, okay, which is the value of the current that going to be supplied, that going to comes out from the potential difference, which is from the power supply. Once for that, once you done that, you are going to open it one by one, the resistor that you calculate before to find the current and potential difference. That's the way that you need to do. Okay. Okay. So, okay. Other than the normal the normal arrangement of resistors, series and parallel, like the questions before, there's another arrangement for the resistor, series and parallel, which we call as a diamond bridge. Okay, but for the diamond bridge, I'm not going to ask you the current and potential difference because it's quite hard, plus it's not as easy as the method that I mentioned before. You need to use another method which we call as the mesh method. But the mesh method is quite higher for your level. That's the reason why for this kind of questions, I'm just only ask you for the resistor equivalent only. Okay. Okay, so for also how to solve this kind of questions. Okay, so basically for the diamond combination is going to be arranged in this kind of shape. Okay, which you can see in front. So for you to solve this kind of questions, you need to understand that we are going to solve it alternate, which means that we are going to we are going to solve it series parallel, series parallel, series parallel, series parallel, but it depends on the situation of the questions. Okay, example like this one. Okay, so you can see that this is what we call as a diamond shape. Okay, for you to solve this question, the first thing that I mentioned before, you need to do it in alternate. Okay, so how to do that? Okay, so you can see that the 2 ohm here is basically in series with the 10 ohm. Okay, you can imagine that how to decide a series or parallel. You can actually imagine the current flow is the water flow. So if you have a junction over there, definitely it's going to be parallel. But example, if actually arranged in one path only, is going to be in series. Okay, the combination of 10 ohm and 2 ohm going to be parallel with what? 6 ohm. Okay, okay, once you combine in electric, the drawing going to be, the combination is going to be in vertical position. So example, if I draw for the 10 and 2. 10 and 2 is basically in series. So I'm drawing only on this part. So I'm going to get the combination in vertical. That's how electric method to solve the arrangement of series and parallel for diamond shape. Okay, so you are going to get like this, and then this, and then this. Okay, so this one going to be 6, this one going to be 6, this one going to be 8. So the combination of 10 plus 2 is going to be 12 ohm here. So once you combine, it's going to be arranged in the vertical position. Okay, so 12 and 6 sorry, 12 and 6 is basically parallel. Like I mentioned before, if you happen to see a junction here, definitely is going to be a parallel. Okay, so 12 and 6, so here you are going to get 1 over 12 plus 1 over 6 equals to 1 over RA. Okay, the combination of this thing I'm calling it as RA. So you are going to get 1 over 12 plus 1 over 6. One answer you are going to get. RA is a 4 ohms. Make sure that you give your answer in decimal point, and please do not give your answer in fraction. Okay, the combination of these two, like I mentioned before, it need to be in the vertical position. So once I combine 6 and 12, I'm going to get this kind of shape. Okay, so this is 4 ohms, the combination of 6 plus 12, and this is 6 ohm, and this is 8 ohm, and this is 6 ohm. Okay, so which one going to be going to be series with the 4 ohms? Yes, okay, because of the same path, that's why 4 and 8 going to be in series. So I put it as RB, which is 4 plus 8, then you are going to get 12 ohm. Okay, once you're done with this, you are going to arrange it in vertical. Remember, the combinations of the calculations going to be put in the vertical positions. Okay, so this is 12 ohm. Okay, which you can see that here, clearly see that is a parallel. So 1 over 6 plus 1 over 12, 1 over RC, you are going to get what value? Okay, I assume this combination going to be RC. Okay, so it's going to be RC 1 over 6 plus 1 over 12. You are going to get RC is 4 ohms. So now you are done with this part. So now focus on the second part. Okay, second part. So okay, so second part. Okay, now the arrangement going to be the combination is going to be placed in the vertical position. So I'm going to focus on the second diamond shape. So it's going to be, here is 4, here is 8, this is 8 also, and this one going to be 4, and this combination is the previous diamond, so it's going to be 4. So from here you can actually see that this one and this one is in series. So 4 plus 4, you are going to get 8, and okay, so I put it as a RD. 4 plus 4, you are going to get 8 ohms. Okay, once you're done, arrange this thing in vertical position. Okay, so you are going to get sorry, this one already done. Okay, this sorry. Okay, so you're going to this one, so you're only left with this and this. Okay, so here, so this is going to be 8, this one going to be 8, this one going to be 4, and this one going to be 8. So 8 and 8, 8 here and 8 here, going to be what, parallel or series? Definitely is going to be parallel. So 1 over 8 plus 1 over 8, I put it as a 1 over RD, the combination of these two. RD, I'm going to get 4 ohms. Okay, but practically this is a um very easy number, but in your questions I'm going to give you like 1.5, 2.2, 3.5, something like that. Okay, once you're done with this, I combine again. I'm showing the diagram for you to understand how to calculate for this thing. So you're going to get, this is going to be 4, so the combination are going to be arranged in vertical. So 8 ohms is here, 4, and this is 4 from here. So definitely a series. So the RE going to be 4 plus 4. You are going to get 8. And once you're done with that, the combination is going to be arranged in vertical. So it's going to be like this and like this. Okay, so you are going to be left with this. And I put the third diamond here. Okay, I put the third diamond here, okay, in our diagram. Okay, so it's going to be this one. So this is 8 from here, this is 8 from the sorry, not from this one, this is from this one, and this is 6. So 8 plus 8, this one, the 8 and 8 is definitely parallel. So you are going to get, I put it here, okay, 1 plus 8 plus 1 plus 1 over 8 equals to 1 over A, B, C, D, F. So RF, you are going to get 4 ohms. So the new diagram going to be, this is 6 and this is 4. So this is nothing. So this one and this one combination in series. So the final answer going to be R equivalent is 10 ohm. 4 plus 6. Okay, so maybe you are not realized that we actually solve the questions in alternate method, which means that, okay, I show you again. Okay, so here is series with this one, parallel with this one, the combination of this series with this one, and the combination of this parallel to this one, series with this one, parallel with this one, series with this one, parallel with this one, and series with this one. Okay, so you can see that it's series, parallel, series, parallel, series, parallel. So but it depends also on the questions. Example, if I put like here without any junction here, so what happen is going to be R1, R2, and RT going to be series. Very good, because only have one path. Okay, so the current flow over there going to be flow in only one path, so it's going to be series. But once you have a junction here, then you need to solve the questions in parallel method. Okay, so I forget to mention here, you are going to start your calculation opposite to the potential difference. So mostly for this point A and point B, we are going to connect it to the potential difference. Okay, potential difference. So maybe the question asks you to find only the I max, the I equivalent. So that's the only questions that I can ask you, but I'm not going to ask you for you to find what is the value for the R10 current, for the R10, what is the current for the R8, because it's going to solve with the different kind of method, which is quite hard. Okay, so make sure that the first step, you are going to solve the questions opposite to the position of potential difference. That's the reason why you are going to start here. Okay, and then you see first the pattern, whether there's a junction or there's only one flow, whether it's going to be series or parallel. Okay, you don't have to draw all the diagram that I draw it for you. This one I just want to show you the steps. Okay, but for the calculations, if example you can combine the questions, combine the calculation, it will be okay, but it depends also on the marks. If I put it as 8 marks, means that you need to completely show your working step. If example I put it 5 marks, maybe there are certain steps that you can actually just combine for you to get marks. Okay, this is what we call as a diamond shape. Okay, Okay, so now we are going to proceed with the terminal voltage. Okay, so the terminal voltage here stands for the remaining voltage after you minus or you plus with the internal resistance. Okay, internal resistance basically is also act like a resistor, which is to limit the current flow. Limit the current flow. So internal resistance here is basically represented by small r. Okay, internal resistance exists in all the electronic instrument, and internal resistance can the value can be increased as the time goes by. But if example, if you bought a new handphone, okay, the internal resistance is going to be very very small, which is below than 1.0 ohm. But after a long time, you can actually see that your battery going to reduce a lot, because the internal resistance, the value of it is already increased, and that's the reason why your handphone would be hot, because it's convert electric energy into heat energy. Okay, okay, so internal resistance or exists now. Okay, our internal resistance here that we are going to say here is about internal resistance in the power supply. So if example the question state ideal, the ideal battery of the, if the question state ideal ammeter, ideal, it means that no internal resistance. Okay, but if example I want to say about internal resistance, mostly I'm going to represent by small r. Capital R represent by external resistor. Okay, so now we are going to find the terminal voltage. Okay, example, when you bought a battery, it's going to be 5 volt. However, if we have an internal resistance in that battery, which is mostly all the electronic equipments have an internal resistance, you are the potential difference that you are going to provide to the circuit not going to be 5 volt, it's going to be less, maybe 4.98 volt. So where is another 0.02 volt? This one is going to convert into heat energy. Yes, okay. Why it reduced? Because of the value of the 5 volt already minus with the potential difference drop at the internal resistance, and that's the reason why you get only 4.98 volt. But 4.98 volt, the efficiency is still higher because the internal resistance is quite smaller. But example, if you use it after like 3 or 4 years, you can actually see that maybe the 5 volt going to provide you only with the terminal voltage of 4 volt. Another 1 volt going to be a voltage drop in the internal resistance. Okay, so that's mean by in terminal voltage. Terminal voltage, it means that you need to find the remaining voltage after you plus or you minus with the internal resistance. Even though I state before is because of voltage drop, there's a certain situations where your terminal voltage is higher than your EMF. And what does it mean by EMF? Okay, EMF, what we can actually say that EMF is an electromotive force. It's not a force, it's just a name. Okay, EMF is basically a power supply, original power supply, original voltage without any current flow. So means that you didn't connect to the circuit, that is going to be your EMF. Once you connect to the circuit, if the power supply have internal resistance, then we are going to call it as a terminal voltage. Okay, so terminal voltage is basically the voltage or the remaining voltage after you connected to the circuit. Okay, after you connected to the circuit. Okay, but for EMF, or we call as the electromotive force, which is represented by this symbol, this is basically the true value of the true value of potential difference, or we can actually say that as a voltage without without connected to the circuit. Okay, so like the example I mentioned before, you bought a battery of 5 volt, that is going to be your EMF, but 4.98 going to be your terminal voltage. Okay, by example, if the question state ideal voltage, it means that your EMF going to be your terminal voltage, which is 5 volt, which means there will be no internal resistance. Okay, here we are going to proceed with bad EMF. Okay, what does it mean by bad EMF? Okay, bad EMF is about the flow of current which not going to follow the conventional current flow. Okay, the conventional current flow going to be from positive to negative inside the circuit, positive to negative. But when it comes to the back EMF, is going to be the other way around, which is negative to positive, which means that is going to follow the electron flow. Okay, back EMF we call as a charging. Conventional current flow we call as a discharging. Okay, and for the charging, you are going to expect that your terminal voltage, the value going to be higher. The terminal voltage, the value going to be higher than EMF. But discharging, the value of terminal voltage going to be lower than EMF. Why? Okay. I'm going to explain that after this using the calculations, which you can actually easily see the reason why it's become more or less. And I just want to mention here, for the charging, is going to convert the electrical energy to any kind of energy, whether it's going to be chemical, like you charge your battery, your handphone battery, you are going to charge it. It means that the electrical going to convert into chemical, or it can be like a motor going to convert electrical into mechanical. Okay, for discharging, it's going to be like a battery. When you connect to the circuit, the conventional current flow from positive to negative going to cause you a discharging. Another example going to be generator. Okay, generator basically convert from mechanical into electrical. Okay, like battery is convert from chemical into electrical. Okay, so the difference between discharging and charging. Okay, I think you guys already know how about this, how it works, how the battery works. Just I want to emphasize that when it comes to the battery, okay, battery basically convert the energy from chemical to electrical. However, when it comes to motor, is going to convert from electrical to mechanical, which means that for the battery, this one is going to act like a discharging concept, which means that the current flow going to be follow the conventional current from positive to negative inside the circuit. And for reversing electrical current, this one we call the back EMF, or the other name is charging. This one going to follow the directions of opposite to the conventional, which is negative to positive. It's going to follow what? Directions of electron flow. Okay, so here, this is the difference between discharging and charging. So okay, I think maybe you guys already see how already know how to get this formula. Okay, please take note, EMF is the one is the value of potential difference, that the original value of potential difference, which means that you didn't connect it to the circuit. But terminal voltage, it means that the remaining voltage after you minus or plus with the internal resistance. Okay, when it comes to the discharging, okay, I draw it, discharging concept. I have a battery here, I have internal resistance here. Okay, this one is external, but this one we ignore first, because terminal voltage is only happen at the battery. Okay, we only focus on the battery when it comes to terminal voltage. Okay, so you have internal resistance here, you have potential difference here. So when it comes to terminal voltage, it's about at the power supply or the battery. So now, if example, you connect to the circuit and the current flow is basically the conventional one, which is moving from positive to negative. Okay, so terminal voltage represented by VT is basically the EMF. Okay, EMF here. Okay, this follow like this, right? Direction this, right? Okay, so from lower to higher, from negative to positive, you are going to take the as the output value. Okay, so it's going to be positive EMF. So this is going to be EMF. Okay, and then at the internal resistance, there always be a voltage drop. When it comes to a voltage drop, then it's going to be minus with the IR. This is basically voltage, which means that the voltage drop at the internal resistance. That's the reason why you are going to get this formula, which is terminal voltage is the EMF minus IR for the discharging concept. Okay, it's follow the conventional current flow. And how about charging? Charging, like I mentioned before, like motor, or you charge your battery handphone. So example, if I show you for the circuit, okay, I ignore the external resistor. Okay, I just focus only for the internal resistance. So you have this one, EMF and internal resistance. So the question asks you to find the formula for charging process. So the flow of charging process going to be opposite, going to oppose with the normal conventional current flow. So it's going to be in this direction. Okay, if you clearly see that here, the potential difference going to move from where? From higher to lower, from positive to negative. So we are going to take the value that the output value. So it's going to be negative EMF. Okay, and then why you minus here? Because internal resistance always voltage drop. That's why it becomes minus IR. So supposedly for the internal resistance, you are going to get negative terminal voltage. But to make it easier, that's the reason why it cancel out all the negative, and then the value going to be VT EMF plus IR to make it easier for your calculations. It's changed from negative to positive. That's the reason why you get this formula and then you get this formula. Okay, so for charging, when you see that the current flow is opposite to the conventional current flow like this one, then it's going to be for charging process. If you see that the conventional current flow is going to follow the discharging formula, which is EMF minus IR, for the charging is going to be EMF plus IR. And that's the reason why I said before, for the charging, your EMF, your terminal voltage is higher than your EMF. But for discharging, your terminal voltage is lower than lower than your EMF. Okay, got it? Okay, that's how you get the formula. Okay, but please make sure that you detect first whether it's charging or discharging. Okay, but example, if the question didn't state anything, it's mostly about discharging. If the question want to state about charging, it's going to put some info over there to represent charging process. Okay, so like I mentioned before, the terminal voltage is all about at the battery. Okay, terminal voltage is all about the battery. You don't have to focus on the external resistor. You only focus on the battery or any power supply. Okay, for the terminal voltage. Okay, so here the green one is basically for you to measure the remaining voltage, or we call as a terminal voltage. If I state to you terminal voltage, you need to make sure that you find the remaining voltage only at the battery. Okay, so this is basically the formula, but it's going to be plus minus. It depends on charging and discharging. Okay, Okay, remember here, all the sources of EMF, whether it's battery, whether it's power supply, have an internal resistance, but the value going to be big or small, it depends. Okay, but somehow there's certain time where I'm going to put, like example, I draw you the battery here. Okay, and then I put it as a 5.0 volt with the 0.10 ohm. Okay, what does it mean? Okay, when I put it like this one actually represent EMF and this one represent internal resistance. Okay, I didn't give you the terminal voltage value. Mostly I'm going to give it to you like this one. I'm going to give it to you the value of EMF. Okay, but there are some questions that I'm going to separate it for you, like this one, where this is 5 volt and this is 0.10 ohms, but you need to detect I think it's better for you to recognize, because this is like a favorite pattern when it comes to the question. Okay, okay, so when it comes to this, when it comes to the EMF or back EMF, or we can actually say charging and discharging, make sure that the first thing first, you need to see the current flow. Okay, because when you see the current flow, you are going to detect whether it's going to be charging or discharging. And if the question state about terminal voltage, you only focus on the battery or power supply. Okay, if example question state about ideal battery, it means that there will be no internal resistance. Okay, ideal battery or power supply, it means that no internal resistance. Okay, so now example, if you have these questions, okay, this question doesn't state whether it's charging or discharging. Like I mentioned before, if the question doesn't state or you don't have any diagram, then you actually put it as a discharging process. Okay, so now the question asks you, a battery is known to have EMF of 9 volt, which is the true value of EMF without connecting to the circuit. If a 1 ohm resistor is connected to the battery, the terminal voltage is measured to be 3 volt. What is the internal resistance of the battery? So the question asks you to find the internal resistance. Okay, the 1 ohm here is external resistor. So how to do this question? Okay, so we are going to use the terminal voltage formula, which is Vt equals to EMF minus IR. So the Vt here, we are going to open it with the IR. R here is external resistor. EMF minus IR. The question asks you to find the internal resistance. Okay, okay. So here you are going to rearrange the formula first. Okay, and then what going to be happen is I'm going to put it R equals to IR minus R equals to EMF minus IR over I. Okay, so this one you are going to get R equals to EMF over I minus IR over I. So here I'm going to get V equals to IR. Okay, because now our problem is we don't have any value of current, so we actually just EMF equals to EMF V over R minus this is capital R, right? This is capital R. So I'm going to get is R equals to EMF over V minus 1. Okay, so just insert the value. Supposedly I'm going to get internal resistance as 1, EMF is 9, V is terminal voltage is V minus 1. So I'm going to get the answer. Okay, so the answer is going to be 2 ohms. Okay, so this is one of the method. You can actually use any method. But as you can see that terminal voltage here, you can actually put it as a IR. But the problem here, we don't have any current. So, and then the question asks you about internal resistance. So this is one of the method you can actually use. Okay. Okay, so this is the proper working step that I already put it for you. Okay, so for this one, for this one, I want you to try the question first. Okay, so even though this question didn't state the whether it's charging or discharging, but you can actually see that the directions of current is from positive terminal into the negative terminal, so definitely it's going to be discharging. So this question asks you about the current in the circuit, but here it already give you the external resistor, the internal resistance, and also EMF. So just use the formula of EMF equals to, terminal voltage, EMF minus IR. So this one going to be IR, minus IR. So the question asks you about the current in the circuit. So here I equals to R plus R, EMF. So supposedly you're going to get I, EMF, R plus R. Okay, and then once you find that, supposedly for the current, you are going to get the terminal voltage for question B. Okay, so basically I already show you the working step here. You can actually double check your answer, but please do it by yourself first before you refer to my answer. Okay, so this is a very simple questions. Please practice. This is going to your answer. And here I just want to emphasize that for the question A, it doesn't state charging or discharging, but like I mentioned before, if the question didn't state, then you go for the discharging. But example, if the question want to state about charging, is going to be like when it's delivering 8 ampere, this is discharging. When it is being charged, and then it's called charging. So it means that there will be some information to represent charging if the question want to ask you about charging process. Okay, so I already put 2 practice questions for you. So this is the question that you need to find the current and the battery for each resistor shown in the figure. Okay, and then here is the answer for question A, and I already put here the question answer for question B. Okay, so please try by yourself first, and if you have any question, feel free to ask. I'm going to show you if you want to, but I think this is a very good practice for you. Okay, and then here also another practice for you. Basically you're going to do the same thing where you need to find the current and potential difference based on the question given, but here make sure that you know which one that you need to start for you to find the resistance, equivalent resistance. Okay, so from there find the current equivalent, then from there you need to find the for each potential difference, find the resistor for find the potential difference and current for each resistor. Okay, so that's all for now. Okay, so I'm going to see you with the next part, which is Kirchhoff law. So if you have any questions, feel free to ask, and I'm going to see you this Wednesday during online teaching. So thank you very much, and bye bye.